In this nugget, we start off with kind of a high-level view of various server roles, and this really starts off with what kinds of versions of Windows are out there. And we'll really start not only with server Windows operating systems, but also client operating systems, starting clear back from DOS, because you might still have some clients out there that are really DOS-based clients, and as we go throughout this whole series, we're going to see that there are certain incompatibilities with some of those older clients. Then we'll look at the versions of Windows Server operating systems that are available here as well, and why some of the current Windows operating systems are going to be better. And we'll also take a look at the servers themselves. I mean, what kinds of servers are available? Primarily, we'll be looking at Windows 2000, Windows Server 2003 servers, and the various iterations of each one of them. Which ones are good for web servers? Which ones are good for domain controllers? That kind of thing. Then we'll see the system requirements. There's certain hardware requirements that you need to have in place there so that you can meet the minimum processing power and all of that. Now, for servers, that's not usually as much of an issue. Usually for servers, you throw as much hardware at it as you can so you can take advantage of the performance there. But we'll take a look at the requirements at least, and we'll also see what they can handle in terms of the amount of memory and processor, for example. And then we'll look at the various server roles that are available, web servers, domain controllers, all that kind of thing. Well, I don't know what the operating systems are in your organization, but one thing you've got to really consider when it comes to planning and implementing server roles and server security is not only what kind of servers you need to roll out and deploy and manage, but also what kind of desktop clients you need to use. Because unless the desktop clients can make use of the servers, then you're not going to get much use out of the servers. So it might be an application that you've got on a server that your clients are not capable of using because of compatibility issues. Or you might also have to consider security issues. I mean, most of your down-level clients are not going to be as secure as more modern Windows clients. And by the way, when I say down-level Windows clients, I mean something like DOS, Windows 3.1, Windows 95, 98, Windows ME, any of those DOS-based operating systems, as compared to modern Windows clients, which would be Windows 2000 or later, including XP in 2003. So let's go ahead and take a look at both of those veins of operating systems. And we see two different stories here from Microsoft's operating systems. And the original one, of course, really was DOS, which Bill Gates bought DOS, decades ago for a song practically. And now he's grown it into this multi-billion-dollar empire. But this is where the cash cow got started, if you will, with a disk operating system from way back when. Well, we thought that we kind of got rid of DOS back in the 80s sometime, but really we didn't, because it just graduated into Windows 3.1. You see, Windows 3.1 is just DOS with a graphical user interface. The guts of it really is still just DOS. And somewhere along there, I can't remember when exactly it came out, but there was Microsoft Bob that came out, which was a very user-friendly, they thought at least. They thought it was going to be user-friendly and intuitive for basic like home users and non-professionals with computers. Well, it turned out to be so stupid looking and everything that people's intelligence were just insulted by it, and it was a horrible failure. But anyway, so that one kind of got crossed off, and that was really never used in corporations. But 3.1 got graduated into Windows 95, and there was a big issue for that because the interface with 3.1 was pretty clunky, and they were also trying to compete against another very popular graphical user interface known as Macintosh, I think you know. So they graduated to Windows 95's interface, but still at the core, we're still starting with and finishing with DOS, again, with just a prettier face on it this time. And then Microsoft did other things to jazz it up a little bit, compete a little bit more with Macintosh. They have the Plus Pack for Windows 98, which came out a few years later, of course, in Windows 98. And then there was also Windows ME. Now, Windows ME is really pretty much the same thing operationally as Windows 98, and again, it all traces back to DOS. Now, some of you are looking at this and you say, James, that doesn't really matter to us. I mean, these are all DOS-based operating systems. What good are those? Well, the rest of you are saying, James, we're still using Windows 95. What are we supposed to do? We're still using Windows 3.1. What are we supposed to do? You see, there are a lot of organizations, even big ones, that have really old operating systems, and yet they're looking at moving up to servers like Windows Server 2003. Well, how is that going to affect things such as performance, application compatibility, security? Security is the big one there. I'll just tell you that right now. Because these operating systems over here are not capable of the sexiest security features that you can get in Windows 2000 XP and Windows Server 2003. Well, my objective here is not to identify every single feature and so forth of all of these various older operating systems, because, among other things, you may have worked with a lot of those in the past yourself anyway. But when it comes to whether or not to use these operating systems, or maybe one of these, especially on the desktop clients right here, we have to consider two key features besides cost, because that's always something that bean counters are concerned with. The first one is going to be application compatibility, and the second one is going to be security. You see, a lot of the management within organizations that know a little bit about technology, but they're not necessarily as technically involved as you are, they don't really care whether or not you're going to get some of the hot new features of these new operating systems. I mean, they're not trying to be trendy. I mean, even though the mullet cut went out with Windows 95, and even though the Macarena went out along with Windows 98, they don't care about being trendy in terms of technology. All they say is, do we have to spend more money? And if we do, you better show me a darn good reason why. This also has big impact when it comes to that application compatibility that I just mentioned. I mean, they may have spent, $100,000 or more on some custom application that they had designed to work with DOS and or Windows 3.1 years ago, and they don't want to let go of that. They say they invested that, they're getting their money's worth out of it. And if you guys move up to Windows XP for your desktop clients, well, they're going to have to completely rewrite the application, or the people that originally wrote the application went down with the .com bust a few years ago. So they don't even know how to get a hold of those people anymore, and, it could be kind of a mess like that. Hey, I'll give you a good example of this as well, by the way. A friend of mine, Jeremy Moskowitz, who's written the only authoritative book on group policy objects, he and I went to the Star Trek Experience, which is in at the Hilton in Las Vegas. We went to a conference there not long ago. And I'll show this to you. It's on the website here real quick. I think I got it here somewhere. Let me go to my favorites. Oh yeah, there it is. The Star Trek Experience. And this sounds unrelated, but really it is. Let me tell you why. We went to the Star Trek Experience, and you can see the Borgs, and they'll chase you around a little restaurant called Quarks there and stuff like that. And they have a new ride. It's not really a ride. It's kind of just a drama experience called the Borg Invasion 4D. And it has a lot of automation and kind of robotic events that take place, and the Star Trek lift doors open and close, and all these different kinds of things happen, and various sirens and alarms when the Borg are invading go off. Well, what's funny about this is this. As Jeremy and I were leaving, this is a brand new experience. They just finished building it. As we were leaving, we got a glance at the control computer that handles all those robotics and all that automation and everything like that, and guess what it was? Yeah, you guessed it. Windows 3.1, this brand new high-tech experience at the Hilton in Las Vegas where everything's glitz and glamour and high-tech. Yeah, it's running Windows 3.1. By the way, it's no surprise to me that we tried to go the night earlier, but the ride was closed because the computer system crashed. Big surprise there, huh? But you see, that's also a good example because there are a lot of robotic-type programs or manufacturing plant programs that are written for DOS 3.1, and people don't want to move off of that. They spent a fortune on it in the first place. They don't want to go anywhere else with it. Well, there are some things you can do to make these applications more compatible with these up-level operating systems or these modern Windows clients, but sometimes you do just have to rewrite them. Let's take a look at another issue, and we'll kind of address this next one as we go throughout this series, and if you've heard me teach before, then you've heard me talk about it in other series as well, and that is that a lot of these down-level clients can't work in terms of security issues. For example, none of these will support encrypting file system, which is virtually an uncrackable method of encrypting your files. Nobody's cracked it yet, and the security has only improved with Windows XP, where we're now using AES 256-bit encryption with EFS. Also, you can't use L2TP or tunneling with IPsec, because these clients don't support IPsec either. And that's a very secure method of doing, among other things, virtual private networking. Also, you can use it with wireless clients and stuff like that. So security is a big issue there, and if you can't get your bosses to switch on basis of application compatibility, and if your company has company secrets that prying eyes would really like to see, well, you might be able to put a scare in them and get them to move off just based on security alone to move to a more current Windows operating system. Now, let's address where these come from. David Cutler is a Unix programmer that Microsoft hired years back, and he really was the chief architect for Windows NT. Now, Windows NT really came out earlier than Windows 3.51. That was the first operating system in the NT basis that had any significance, which later graduated to Windows NT 4.0, which is the most popular version of NT. This was the basis of a totally new kernel, and it was not based on DOS. Now, you can use a command prompt, but it just kind of looks like DOS. It's not really DOS. You can just run DOS-like commands from it. Anyway, that graduated into Windows 2000, which was probably the most significant operating system that Microsoft developed. because it had the best features at its time in terms of security, and it did have some pretty good application compatibilities tool that would work with it as well. Now this was a server and a desktop client, as you know, but Windows XP, of course, is just a desktop client, and we're only addressing Windows XP Professional. Because you're not likely to be using Windows XP Home Edition in the corporation. And then, of course, we're on our current topic, which is Windows Server 2003. And then the upcoming version of Windows is currently called Longhorn in its code name. Microsoft has a tendency to name their operating systems after ski resorts, you know, when they're in the code phase. And I think Longhorn's a ski resort out on the west coast somewhere, upper northwest somewhere. In any case, the strength of all these operating systems is that they come from the NT kernel, David Cutler's NT kernel, which is a highly secure kernel, which is where we get the NTFS file system, for example, another security issue, that you cannot get in these previous operating systems. I mean, you can boot from a DOS disk on any computer in these operating systems and get total access to the entire hard drive. In fact, you don't even have to do that much. There's a lot of different ways to get to that. Well, under NT4 and these operating systems, these NT-based operating systems, you can't really just do that if you've got an NTFS file system. Now, there are ways of getting around it, but it's a lot more work to do so in most cases. Now, I say that these are all NT-based operating systems. When you get to Longhorn, there's a bit of an exception there. There's still some common philosophy that stems from NT, but really we're developing a new kernel down there. And I've talked to people at Microsoft, and I've talked to them about some of the new things that are coming out there. Some of the things that are coming out, by the way, are the file system is going to be new. And we're not going to really address this in detail here because this is just for the future and it's still in beta. And I don't want to teach a, just beta product right now. But the file system is going to have its basis in SQL, not just NTFS, but in SQL. So if you don't know much about SQL yet, you might have to learn some things about SQL to really manage in great detail the file system within the upcoming version of Windows, which by the time you get this, will probably be named something like Windows Server 2005 or whenever it's going to be released. So let's just call out Windows Server 2007 and be realistic about it. Here's a quick trivia thing for you, by the way. Windows NT, what does that mean? Well, people think that it stands for New Technology, but Microsoft has never officially said that. In fact, they've really never said what NT stands for. But people speculate that it comes from one of two purposes. Number one, Dave Cutler came from an operating system called VMS, and that's what he was steeped in before he came to develop NT for Microsoft. Well, one common pun by developers is to take the letters of some other operating system and shift them over. So if you take V and the next letter in the alphabet would be W, M, next letter in the alphabet is N, S, next letter in the alphabet is T, Windows NT. So some people think that might be it. More than likely, however, it really comes from an old Intel processor that was codenamed the N10, and it was a failed processor, so never really had any success. But NT really, and this is probably the prevailing theory that's actually correct, NT stands for N10, based upon the Intel processor that never really got off the ground. Then, of course, moving on to the server issues themselves, apart from desktop clients, we have two different veins of servers to work with. And these are really both good servers, both acceptable in today's computing environment. Windows 2000 is and will be for many years to come a strong operating system. Windows 2000, we start off with the professional for the desktop clients, of course, but it has these three versions. It has the server version, the advanced server version, and the data center server version, which is only available from OEMs. You can't buy it off the shelf at CompUSA or Best Buy or something like that. Nevertheless, anyway, these all have different iterations that you can get to. Of course, the further down the list you go here, the more expensive they get, but also the more capable they are in terms of handling a larger number of processors, more memory, and that kind of stuff. Well, in Windows Server 2003, they've taken this an additional step, because now with Windows Server 2003, they've added in this web server item here, because a lot of times in the past, people would buy a Windows 2000 server, and they'd spend a lot of money on it. It's capable of doing a lot of different things, DNS, DHCP, all different kinds of services. It can be a domain control and all of that. They'll spend a few $1,000s on this server, but really all they're trying to do is serve out a web page. Well, Microsoft heard the complaint about that, so they gave a low-cost server, a web server, that cannot be a domain controller, that cannot be a DNS server, cannot run a lot of different kinds of services, cannot be a certificate of authority, all this kind of stuff. So if you just want to serve out basic web pages and you just need a couple of processors, which is the maximum you can put in a server, probably a web server is a good way to go, a low-cost alternative for you, especially if you're running a web farm where you got to buy dozens of copies of this. Then there's the standard edition. This is kind of a more all-purpose type of a server. We can use them for domain controllers. They're commonly used for that, in fact. Also very good for certain kinds of application servers and just a good general all-purpose server. Good also for an infrastructure server if you need Win servers, DNS, DHCP, that kind of stuff. Enterprise servers are more for heavier duty applications, or if you need to use some form of clustering where you need to have high failover, high availability, and all that kind of stuff. Also, with enterprise and data center servers, Microsoft does brag about 99.999% uptime, which is also known as 5 nines. And depending on the service contract you have with Microsoft and the hardware that you support, Microsoft will actually support you for a 5 nines uptime, and they'll guarantee that. By the way, there's not very many people that have taken advantage of that. There are a handful, like 5 clients that are on the 5 nines service plan with Microsoft. A few of them are government agencies, which you can imagine some of the importance there. And then the other one, believe it or not, is Starbucks. Yes, that's right. I mean, if Starbucks servers ever go down and we can't have coffee in the morning, this country would grind to a halt. So it's really a matter of national security. In fact, this very morning, I went up to my Starbucks nearby house here. It's almost a bike ride away, but of course I drive anyway. And I go up there and Starbucks is closed. So I had a really slow start this morning and my world came to a halt. And then, of course, there's the very beefy data center version, which is beefy not only in what its capabilities are, but also in its price, as you can imagine. Again, you're not going to buy a data center server by itself. That's why I can't tell you how much it costs, because you buy it with a big old server with a bunch of processors and a whole bunch of memory from some vendor like Dell or Hewlett-Packard or somebody like that. So these are the various types of servers along the Windows Server 2003 vein that you can get. And as we look at that, you should also be aware of this. I've just gone to Microsoft's webpage here. You can jot this down if you like. It's easy to find, too, if you just browse around Microsoft's website. You'll get here eventually. And it's important to know what kind of hardware capabilities in terms of its minimum requirements and its maximum requirements are here. And let's go ahead and take a look at that also. Now, when it comes to the operating systems that we have here, and by the way, I just want to point out that this is a little counterintuitive the way Microsoft did this. I think they should have started with the least capable server, so they should have put the web edition over on the far left, and then moved up to standard enterprise and data center. But anyway, this is just how they did it. Anyway, with the operating system requirements here, you're not going to really be too concerned for servers with the minimum CPU and the minimum memory and minimum disk space. That's really going to be more of an issue on client desktops, because we have issues there where we want to get by with just the bare minimum. And if someone's just running Microsoft Word and maybe Outlook every now and then, well, you probably can get by with bare minimums there. With servers, however, the whole point is to get maximum performance. So it's unlikely that you're going to put any of these operating systems on these bare minimum CPU speeds, or even the recommended CPU speeds are pretty much going to be slow. I mean, if you're going to spend, $5 grand on the Enterprise Edition here, and you're going to put it on a 733 megahertz processor, that just doesn't make good financial sense, because you're not going to get the best features out of this Enterprise Edition in terms of its performance. Anyway, that's kind of a philosophical statement, but the facts remain here in terms of what Microsoft recommends for the minimum and recommended CPU speeds. A little bit unrealistic, but there you go. The minimum RAM, again, is also pretty unrealistic. I mean, if you're going to spend tens of thousands of dollars possibly on a data center server, and you're only going to put 512 megabytes of RAM in it, that's just not very realistic. Even a gigabyte on today's servers is not that realistic. You're going to have several gigabytes in there. What's probably more pertinent to our discussion is going to be the maximum RAM and maximum processor support. The maximum RAM on the standard edition is going to be 4 gigabytes. Now we're talking about a real server here. Now, if it's just a domain controller, which is a very important server, but it doesn't really require a lot of resources, you probably only put a gigabyte in there. Unless you've got tens of thousands of users, well, then you might need to beef that up. So a lot of this depends on what kinds of things you're trying to support. But if you support 500 users, you got a gig of RAM in there, you're probably going to be just fine, because really, it's not that memory intensive as just if it's just a domain controller. Now, let's move on to some other things here, though. 32 gigabytes on the advanced version of Windows Server 2003, and you can also go up to 64 gigabytes on Titanium based. By the way, the reason why it can go up higher is because we're working with 32-bit processors here, and we're working with 64-bit processors here, so it's able to support more memory. In any case, this would be much more pertinent to know about in terms of how much maximum memory it can put into these servers, because you may have applications or large databases that want to cache quite a lot of data. And in that case, yeah, you might need all 32 gigabytes of RAM for that. When you go into the data center version, then you're going to maybe need 64 gigabytes of RAM. And that'll be a pretty beefy server, but it's going to have a lot to do. And again, Titanium goes up to 512 gigs. Your web server can go up to 2 gigabytes. That'll probably be just fine. 2 processors, 2 gigabytes on those web servers. only if they're heavily utilized. Maybe they have sophisticated applications that they have to run as well. You can have pretty good web server with those kind of requirements. And again, like I said, the web server supports up to 2 processors as well. Now, the standard edition supports up to 4, and again, that's good for an all-purpose kind of a server. And then you can go up to 8 with the Enterprise Edition, and 8-way minimum capability for data center, up to a maximum of 64-way processing on the Data Center Edition. Now, whichever of the servers you decide to use, whether you can use a data center server, just a web server, a standard server, each one of those can take various types of roles. Some of those servers can't use some of those roles. For example, a web server cannot be a certificate authority or a domain controller or a DNS server. However, these are the various kinds of roles that can be implemented. And here we're just going to kind of look at the purpose of these different types and some various general considerations for each one of them. Now, there may be web servers out there that are beefier and that have higher demand on these web servers than some of the smaller companies that use domain controllers. So you might actually have a web server that your web server may beat my domain controller in terms of its total horsepower and all that kind of stuff. So some of this is going to be very relative. However, as a general rule, your web servers are going to need to have capabilities to handle a lot of network requirements. For example, if it's an intranet web server that's heavily used by your internal users and you've got tens of thousands of users and you've got your own web farm just for those users, well, you're probably going to have multiple network cards to those web servers so you can get a higher level of throughput to the web server. You might want that to be more reliable in that term as well. So you probably use something like network load balancing, which we'll talk about a little bit later on in this series. Also with those web servers, if you can use a lot of scripts or web type applications, or if you got a lot of Java kind of stuff running on them and stuff, well, Java is supposed to run the application on the client side, but there still requires some processing on the server side. But if you got any of those kind of applications running over here on the web servers, then again, you have to consider those things as well. So you might need a little more processing power. Remember, on a web edition, you can use up to 2 processors. And then there are infrastructure servers. And these provide a different kind of service. They're a little bit more general. You can use DNS, DHCP, WINS, all those different kinds of services can be used on what we call an infrastructure server. And of course, it's not limited to these roles. You might also use it as an RAS server, some other kinds of functionality. But generally speaking, these kinds of servers still need somewhat high capability in terms of handling a number of client requests. Especially, for example, let's say a DNS server. If this DNS server is handling all of your internet queries as well as all of your intranet queries and so forth, well, it's probably going to do quite a lot of referrals out to the internet, but it's going to be a lot of traffic going back and forth through that DNS server. So you want to make sure that its bandwidth is pretty open as much as possible. And again, you might install multiple network cards there just to give it better availability in terms of its throughput in the network. And then the DHCP server. Initially, it's going to get a lot of traffic if you turn it on today and everyone starts leasing addresses right now. But over time, it'll just have to have kind of a consistent network presence, kind of a consistent availability on the network. But you're not going to get a lot of bursty traffic through that with a DHCP server. A little bit more chatty traffic goes to your WINS server because it registers several different kinds of record. So again, you're going to need always-on connectivity with that. And again, possibly not real high throughput, not as high as throughput as a heavily used DNS server, but it's still definitely going to need to be available. And it's going to have to handle a higher number of requests at a time. Now, when it comes to a file and print server, we've got a whole different kind of a scenario going on there. Now, naturally, all of these need network connectivity. I kind of mentioned that with these infrastructure servers, for example. All of them need network connectivity. It's just the kind of network connectivity they need and the kind of considerations you need to keep in mind in terms of how they use the network. For example, these kinds of servers are very small packets that are transmitted, and they're just kind of blinks on the network. They're not really heavily utilized in terms of broad throughput. However, a file server, maybe I've got a multimedia department that has large movie files on that file server, and I got many of my media technicians uploading and downloading several hundred megabytes at a time. Wow. Well, that file server is going to need quite a lot better network throughput because it's more bursty and it's got high utilization at a time. So we're going to have to keep that in mind. Also, with a file server, you're going to need more disk space. I mean, these kind of services up here require hardly any disk space above just the default installation. A file server has who knows how much file requirement in terms of its disk space. So I may have to put in an additional RAID array of some kind there. You're also going to have something like some kind of a redundancy involved. You might have mirroring, you might have a stripe set with mirroring, you might have all different kinds of disk arrays, depending on the requirements that you have, to make sure that its data stays safe. And I mean that besides just a regular backup. So we're going to need a lot of storage there, and it might need to be very fast storage. That's why we need RAID. And then you might also need RAID for a print server, because print serving, those spool jobs are highly disk intensive. Again, though with a print server, you don't really care if the print job is lost. I mean, if someone loses a print job, it gets corrupted or something, they just start over again. They don't actually lose the data file that they were printing from. So we may not care as much if it's just a print server. You might put in something like a RAID array that's just striping. You don't really need stripe set with parity, because you're not going to need to reconstruct print spool jobs. You might not use a mirror, because that has a lot of high overhead in terms of the wasted quote-unquote disk space, because if you got two 10 gigabyte disks in a RAID array, you really only have 10 gigabytes of useful data. Well, with a stripe set, you're going to get better cost effectiveness out of the stripe set, and you're going to get better performance out of it. So these are all things that you got to consider in terms of how these things are used. So again, with our web servers, we're going to have a big emphasis on network connectivity, as well as with our infrastructure servers. We still need that with our file and print servers, but we're also going to add on to that disk utilization. We need to really have a lot of disk space or a lot of fast disk space, or both, with the file and print server. And then your email server, boy, that's one of your most high-profile servers that you'll have. I mean, if users can't print for today, well, that's fine. They'll just wait a few minutes and try to print again. But if somebody can't get their email, boy, they're screaming at you right now. I mean, that's a highly visible server to keep up. So we're probably going to put that on a clustering solution of some kind, so that we can make sure that email is always available. And that way, if one of the email servers goes down, other email servers can fill in for it. And there's a lot of different ways to make that redundant. So it does need some network connectivity, of course, especially if you're going to also process internet mail. Maybe you got POP3 mail coming through it and all that kind of stuff. But probably there's going to be a pretty big emphasis on your email servers in terms of high disk capacity. So again, we're going to really need some disk capacity there. It's going to also need to be fast. And this is partially because we have no idea what kinds of attachments are coming through. Hopefully they're not viruses, right? But in any case, you probably will have an email quota in terms of how much disk utilization each user can use. So that's one way to control the disk utilization. Also, you may have rules in your Exchange server, whatever your mail solution is, in terms of the file size for the attachments that can come through. So you can control some of that. Nevertheless, there's a lot of disk utilization with an email server. Now, you may also be using a DMZ, or a demilitarized zone, as we call it, for several of these kinds of roles. And a demilitarized zone, just as a quick review here, let's say we've got the internet out here, and we've got an internet connection to our DMZ here. And here we've got our various servers in the DMZ. That might be our DNS server, a web server, if we're going to provide internet access to those web servers. It's not just intranet access. Our email servers, if we're getting email from the internet. So all those kinds of servers might be here in the DMZ, and it's protected by firewalls on this end of it and on this end of it before it passes through to our private network over here. Well, the DMZ is where you're going to put a lot of these different kinds of roles. That way we can protect it with one firewall here and from the internet, and then we can protect anything that does get loose in here with this firewall here, protecting us in our private internet over here. So some of these roles, some of these servers will have different roles just based upon where they're located as well. By the way, let me just give you a quick side note here. One of the key project managers at Microsoft, I saw him the other day, he's recommending, and that Microsoft's not really putting this in writing yet, but it looks like Microsoft in some divisions and in a lot of corporations, by the way, as well, they're starting to say, hey, why do we even have a DMZ? Now, it looks to me like it's the safe way to go. And for many of you that have done traditional networking in the past, you never do business without a DMZ. Microsoft is starting to cross this off the list because they're saying, hey, all we need is one user to come home with their laptop, and then bring it back into our organization with the latest virus. And it doesn't matter that we had this DMZ because they loose a virus out here and it still gets on everybody's computer and we get all infected. It goes back up here to the DMZ anyway, DMZ gets infected. So they're starting to kind of throw their hands up in terms of why do we even have a DMZ, and there's a lot of other justifications for that which are kind of interesting. Anyway, this is just kind of a side note to let you know that we might see DMZs kind of start to drift off a little bit because administrators are not managing them the same way anymore or even using them anymore. For our traditional thinking, and for most of what we'll be thinking about here, we will continue to use them, but that is a trend that's coming up. And then the only thing they're really using a kind of a DMZ for is off on their network somewhere. Instead of using this private network where all of our clients are, they'll use a special part of their network, and this is the only part of their network where they will really have highly implemented firewalls and really a lot of security protections down here. And here's where they put their DBase server down here. It's where they'll put maybe their domain controller down here. Other highly sensitive servers will go into this, and they'll really closely restrict the traffic that goes to that private portion of our network. But it's not quite the same as a DMZ per se because it's not directly connected to the internet anyway. And then the way they'll protect their desktop clients and all of that is to just make sure that they all have up-to-date virus protection on them. And then they also have the latest patches and updates and that kind of stuff. And of course, they'll still have a firewall from the internet out here. It's just not going to use the same traditional DMZ structure. Okay, let's take a look at another kind of a server. How about a database server? Database servers can be very disk intensive, and we're thinking of a larger corporation that has a heavily utilized database. Again, you're going to have some kind of a high-end RAID solution. You're not going to be using Microsoft RAID, that's for sure. You're going to be using probably a separate enclosure. It might be a fiber-attached enclosure of some kind, using what we call a fiber channel arbitrated loop, which is extremely high throughput through this database. And so you're going to have high performance disk utilization here. You're also probably going to have to use high processing power. You might have multiple processors on your database server because that is not only disk intensive, but potentially also processor intensive, especially when you get more complex queries that are going on all the time and all that kind of stuff. Again, it's also going to need, and all of these servers, I kind of emphasize networking on these top three, but all of them really need networking, obviously, otherwise they're useless to us. But in terms of the networking for the database server, it's not going to be high throughput as much as something like a file and print server, because most of the data that's sent out to the client is just the results, and all of the processing and actually the heavy lifting is done on the actual database server itself. And then we have backup servers as well. And before I forget, also your database server might need a high memory utilization as well, because it might do a lot of caching there to improve performance for commonly requested queries. Anyway, you also have your backup servers I mentioned earlier. Here we're going to need high network throughput, especially if it's going to back up from all across the network. Maybe we're backing up several file and print servers from that same backup server. We're backing up across the network from our database server. I mean, there might be backup jobs that are taking hours overnight to back up, and it's all taking place over the network. Now, one advantage we have with backup servers is that at least we can do most of that work, in most cases, at night or during non-peak periods of time, so at least we're not competing for network traffic quite as much. Nevertheless, what network traffic it needs is pretty high throughput, so keep that in mind. Also, you might need a little bit of higher memory utilization for backup as well. There are certain kinds of caching that can take place so that it can feed into cache data that's about to be backed up so that it doesn't get behind or it doesn't get a gap in its backup utilization or backup job, and increases the efficiency of your backup jobs. Also, you're going to need to be able to have a backup device of some kind. Obviously, the faster kind of a backup device it is, the better. If you're in a larger corporation, you're going to use some kind of robotics to do that, or some kind of a tape changer. So anyway, again, you're going to need some more memory utilization there as well. Microsoft says for the backup server, you might also need processing power, additional or beefier processing power. I'm not sure I really see that, because really we're just using a single application in most instances to back up. Really, your heaviest emphasis is going to be on the network utilization there. So I'm not sure I quite agree with the processing power thing, but Microsoft says it does. Now that our domain controller, it's probably the most critical of all of these, because if someone compromises your domain controller, then they can get access to something like an administrator account. They can access all of these other servers. So this really starts a domino effect if somebody accesses the domain controller and able to exploit that. So we really want to make it highly secure. That's why some organizations, again, are putting it in an isolated, highly secure network like this over here. But beyond that, what in terms of its hardware utilization does it really need? Not that much, really. I mean, people logging on, it just uses little trickles of traffic for a logon. There are a few packets that are exchanged to authenticate. If it's heavily utilized and you're really using a lot of processing power on it, you might need an additional processor perhaps. But that's because it does do some encryption. I mean, Kerberos itself involves some encryption. By default, domain controllers will require signing or request signing for any SMB traffic that goes back and forth to it, or server message block traffic that's used for shares and things like that. So there's a little bit of encryption that goes on with that kind of a thing. But other than that, in terms of its hardware, it's pretty much just an average kind of a server in terms of its hardware requirements. In this nugget, we took a look at server roles. We started off with a discussion of the various versions of Windows, really going back clear to DOS, actually. We saw that the DOS-based operating systems are not going to be nearly as good, and really those are the client-based operating systems that you can use there. And the Windows operating systems that go back from DOS are not nearly as secure, but they might have application compatibility that you don't have with modern Windows clients, such as Windows XP. And then we also took a look at the various servers that are available as well. We really pretty much addressed Windows 2000 in brief, and also Windows Server 2003, the various versions of Windows Server 2003 that are available to you. Then in order to install those products, you need to make sure that you meet at least the system requirements that Microsoft recommends on its website. Really, the most important part of that probably is to understand how much you can put in them, not how little you can put in them, how much memory they can take, how many processors they can take, and that kind of stuff. And then we look at the various roles that are available for various server requirements as well, whether or not certain kinds of servers are best suited as web servers, which ones might you use as a DNS server, which ones might you use as a database server, and so forth. I hope this has been informative for you, and I'd like to thank you for viewing.